Hello, Algebra 1. Today I'm going to go over a few more examples of solving by completing the square. Okay, you can watch all of this video, you can watch some of this video. It's just a few more examples since our class was so short today. So looking at this first problem here, remember we want to make sure that A is 1. We want to make sure that C is isolated, which it is. After you have, established that those are done, we're going to go ahead and we're going to complete the square by adding a number to create a perfect square trinomial. Remember, again, the way that you get that number is you take your B value, you divide it by 2, and you square it. This is something that can definitely be done in your head, but you can see over here I just did it quickly off to the side to see that that gives me a value of 1. So I'm going to go ahead and add 1 here, but since this is an equation, if I add it to one side, I must add it to the other side. After we've completed the square, we go ahead and we factor it. It will factor into a binomial squared. It's always going to be x, because remember the a is 1, so it's just going to be x squared, so that's x times x. So in a binomial squared, that's x. And then it's going to be minus 1. Remember that this value here will always match up with that number here. So that's a really good way to quickly factor it. Bring down the equal sign, simplify the other side to 4. In our next step, we go ahead and we square root both sides. In order to continue solving this problem for x, we need to undo the squared in order to get to x that's inside that parenthesis. Anytime you square root something that's squared, basically what it does is it cancels out that squared, giving you just the base x minus 1 equal to, don't forget plus or minus, because we know that we have to consider both cases of squaring a number. And square root of 4 is actually a perfect square. It's 2. The next step is to continue solving by getting x by itself. So I'm going to add 1 on both sides, leaving me with just x equals. Remember to always write the plus or minus in the middle. So that means I'm going to have a positive 1 plus or minus 2. Now you're not quite done, because this 1 plus or minus 2 represents 2 answers. Those answers are going to be x equals 1 plus 2 and x equals 1 minus 2, giving you answers of 3 and negative 1. So if you were to graph this quadratic, if it were in standard form, z equal to y, these are the 2 values that would represent our x-intercepts. Okay, let's look at another example problem here. In this problem, I have 2x squared plus 20x equals, minus 8 equals 0. So this one's in standard form. Okay, so with this problem here, the first thing I notice is that a is not equal to 1. So in order to get a equal to 1, we're going to divide to make a be 1. In order to make a 1, I would have to divide a by itself. I'd have to divide it by 2. But in an equation, if I divide that term by 2, I have to divide all the terms on both sides by 2. So I'm going to go ahead and do that. Divide by 2, divide by 2. It's kind of like you're factoring out a 2 in a way, but we're dividing it out because it's an equation. We can do the same operation on both sides to every term, and it'll help to cancel it out to a 1, which is what we want. Leaving me with x squared plus 10x minus 4 equals 0. We're going to go ahead and isolate the c by adding 4 to both sides. Again, that work could be done in your head. I'm going to cancel that out, leaving me with x squared plus 10x equals 4. Notice I left a space thinking ahead to my next step where I'm going to complete the square by taking b over 2 and squaring it. b over 2 is 5. Squaring the 5 will give me 25. So I'm going to go ahead and I'm going to add 25 right here. And due to the fact that this is an equation, I have to add it on the other side as well. Okay, so factoring this to binomial squared, it's going to equal the simplified side, which is 29. All right, so again, because it's x squared, it's always just going to be x. I look at this number over here, I see a positive 5. I know that this is what it's going to be. It's just a pattern. Patterns are really nice to follow, but you could always factor this, guess and check into 2 binomials, and you will see it factors into 2 identical binomials because it's a perfect square trinomial. My next step is going to be to undo the squared, so I'm going to square root both sides. And because square roots and squares are opposite or inverse operations, they undo each other, leaving you with, in this case, the base, which is x plus 5, equals, we need to consider both cases for the square root. So I'm going to do plus or minus square root 29. Then I'm going to go ahead and get x by itself by subtracting 5 on both sides. And that leaves me with x by itself equals negative 5 plus or minus the square root of 29. Again, this is 2 different answers. It's x equals negative 5 plus the square root of 29. And it's x equals negative 5 minus the square root of 29. Now, in your textbook, they want you to put this into the calculator and round it to 2 decimal places. So remember, you can always use Desmos for your calculator and get your decimal values following the rounding rules to round it to the hundredths place, possibly. Okay? All right. I'm going to do one more type of example. And you're not going to see problems like this in your homework, but I just want to show you what happens when we have a different kind of b value. If you've noticed, every problem that I've done so far, the b value has been an even number. Let's see what happens when the b value is maybe an odd number. So I'm going to make this one so a equals 1, and so the c is already isolated, okay? All right, so on this problem here, because a equals 1 and c is isolated, I can go directly to completing the square by taking my value of b, which is negative 5, dividing it by 2, and squaring it. That will give me positive 25 over 4, right? And we're going to leave it in fraction form. Okay, so that means I'm going to add a 25 over 4 here, and I'm also going to add that to the other side. Okay, I then have to factor my trinomial. When I factor this trinomial, remember, because a is 1, the x, it just becomes x, because x times x is x squared. Remember, it's binomial squared. To figure out what number goes here, use that little trick that the number that goes here is the b over 2 value. Okay, so I'm going to go ahead and use that trick to help me easily factor this to x minus 5 over 2 squared. And that's going to equal whatever I get when I simplify this. So off to the side, we're going to do a little bit of 4th grade math over here. I think it's 4th grade. But I need to make common denominators to be able to combine these two. So I'm going to put the negative 3 over 1. The common denominator is going to be 4. So I'm going to multiply this by 4, which means I have to multiply this by 4. Giving me negative 12 over 4 plus 25 over 4. When you add fractions with the common denominator, you keep the denominator, combine the numerators, giving me a value of 13 over 4. Okay, so that's what you're going to get over here. 13 over 4. All right, so you can see how that odd number for B makes it a little bit more challenging to do completing the square, but it still works, okay? Completing the square can be used to solve any quadratic, which is one thing that's nice about it, but they can get tricky and messy with all the fractions, but that doesn't mean they're not doable. So square rooting both sides to get rid of the squared is going to leave me with x minus 5 over 2 equals, all right, square rooting 13 over 4. Because we're giving our answer in decimal values, I'm just going to go ahead and leave it as the square root of 13 over 4. Okay. And then I'm going to go ahead and add 5 over 2 to both sides. And that's going to give me 5 over 2 plus or minus the square root of 13 over 4. Okay. So this is where we can stop. We can split it up. We can find our decimal values. Again, sometimes they will ask you for it in radical form. We are concentrating on just getting it to that decimal form. So I would have two answers for x. It would be x equals 5 over 2 plus the square root of 13 over 4. And then I would also have 5 over 2 minus the square root of 13 over 4. Okay, putting it in radical form is something for another lesson, which we won't be talking about at this time. So keeping your answers like that, you can type that into Desmos to get your decimal answer, round it to whatever place they would like you to round it to. Okay, so I hope you guys enjoy these examples and that they helped you out, and best of luck with your practice.